Hello, everyone. For the first hour, I'll be taking the session, and then the 30 minutes we can go for question answer session, just like yesterday. Okay, so yeah, let's have a look what Jupiter has to tell about itself. Let's see. It's called the giant gas planet. Why? Because it is mostly made of gas. It is the fifth planet from the Sun and the largest planet in the solar system. It's also called the Lord of Heavens. It is a gas giant with mass 1,000 that of the Sun, but is 2.5 times the mass of all other planets in the solar system combined. So look at the size of mass of Jupiter. It has only 1,000 that of the mass of the Sun, but you know it's 2.5 times. Just add up all the masses, all the other masses in the solar system, 2.5 times. Then we'll get the mass of Jupiter. That massive is Jupiter. Now, Jupiter was named after the Roman god who was the leader of all gods. Okay, just like in Indian mythology, we say Devendra, right? God of all gods. Just like that, Jupiter was the Roman god of all gods. And in Roman mythology, Jupiter was the biggest and most powerful god. And because
that was yes.
in Roman mythology, Jupiter was the biggest and most powerful god. And because of these characteristics and its size, the planet was given that same name. Now let's think about how large is Jupiter compared to Earth. Jupiter has a diameter of about 88,695 miles, which is more than 11 times the diameter of Earth. And its volume is 1,300 times the volume of the Earth. See this? It has more than 11 times the diameter of Earth. So you combine 11 Earths. You line up Earth 11 Earths in a line, then you'll get the diameter of Jupiter. Okay. Now, its volume is over 1,300 times the volume of Earth, which means Jupiter is so big that over 1,000 Earth could fit inside it. And Jupiter, is so big that it weighs 2.5 times the weight of all other planets, all of the other 8 planets put together. See, this is the comparison of Earth to the Jupiter. So you can fill 1,000 Earths into Jupiter. So look at its volume. This slide talks about who discovered the planet Jupiter. So there is no single person who is credited with the discovery of Jupiter, because Jupiter is one of the 5 planets that can be seen in the night sky without using a telescope or binoculars. So in the sky, if you see a bright star-like thing, but it's not a star because it's not blinking, that could be Jupiter. We can see actually Mercury, Venus, Mars, Jupiter, and up to Saturn. And after Saturn, we cannot see Neptune or Uranus. Now, Galileo was the first to observe Jupiter with a telescope, as Jupiter can be seen with the naked eye. The ancient probably the ones who discovered it. Jupiter can be seen from planet Earth, and so it is hard to tell who actually saw it first. But Galileo Galilei was the first to observe Jupiter with telescope. Now, Jupiter is composed primarily of gaseous and liquid matter, and it is the largest of four gas giants, as well as the largest planet in the solar system, with a diameter of 1.4 into 10 raised to 5 kilometers at its equator. Now, what would be the composition of Jupiter? Thus, the atmosphere is approximately 75% of hydrogen and 24% of helium by mass. So basically, it is a hydrogen and helium filled planet, with the remaining 1% of the mass consisting of all the other elements. That's the atmosphere we are talking about. Now the interior. It contains denser materials such as the distribution is roughly 71% of hydrogen, 24% of helium, and 5% of other elements by mass. And the atmosphere contains trace elements of methane, water vapor, ammonia, and silicon based compounds. So there are also traces of carbon, methane, hydrogen, sulfide, neon, oxygen, and phosphine, also sulfur. This is the internal structure of Jupiter. Study from the core, it has liquid metallic hydrogen and helium layer, and above that there is liquid hydrogen and helium. And in the upper layer is the atmosphere. And here you can see one of the important features in Jupiter's surface, which is the Great Red Spot. So the first layer, this is atmosphere, and this is
hydrogen and helium layer.
and this one is
Metallic hydrogen and helium.
okay. Everybody, please mute.
So,
Yes, fine. Very good. And now about the mass of Jupiter. Jupiter's mass is 2.5 times that all the other planets in the solar system combined. This is so massive that its barycenter with the sun lies above the sun's surface. Barycenter means even though we say you know all the planets revolve the sun, actually all the planets along with sun is revolving a common center of mass point, and that point is called the barycenter. Just like binary stars, if you have heard about binary stars, how do they actually revolve around each other?
They rotate around each other, ma'am.
Okay, fine. So just like that, since the mass of Jupiter is comparatively higher than all of these other planets, what happens? The barycenter uh, between Sun and Jupiter is in the surface of the Sun at a solar radii of 1.6068 from the Sun center. Now, Jupiter's volume is that of about 1,321 Earths, yet the planet is only 318 times as massive, because Jupiter's radius is about 1 by 10th of the radius of the Sun, and its mass is 0.001 times of the mass of the Sun. So the density of the two bodies are similar. So look at some of the pictorial representation of what we just said. Now, what about the stripes that we see on the surface of Jupiter?
Excuse me, ma'am.
Yes.
In the previous slide, there was some disk given, right? Down in the previous slide. Yeah, what are those two disks?
No, it just means the whole solar system.
Okay.
Now, the stripes of colors on Jupiter are its bands. Whenever we see the structure, the surface of Jupiter, we see different stripes, and they are actually the bands of Jupiter. The light colored bands are called zones, and these are regions where the gas in Jupiter's atmosphere, which is rising upwards. So there are light and dark color bands, right? And if you talk about that, this one is dark colored, and then there is a light color, then there is a dark colored. So it's alternatively it's coming. So the light colored bands, they are called zones. These are the regions where gas in Jupiter's atmosphere is rising upward. So in those areas, in its areas of Jupiter's atmosphere, the gas is rising upwards. And whoever who is yeah, please don't scribble in the screen. It can be visible to everyone. That's why, not only to your own computer. So the dark bands are called belts. So the light bands are called the zones, and the dark bands are called belts. Yeah. These are regions where the gas in Jupiter's atmosphere is sinking downwards. So in the zones where it is lighter colored band, the gas is coming up, and in the Jupiter's dark bands, which are called belts, the gases are sinking down. Now, how strong is the gravity on Jupiter? The gravity on Jupiter is greater than the gravity of Earth because Jupiter is more massive. Although Jupiter is a great deal larger in size, the surface gravity is just 2.4 times that of the surface gravity of Earth. This is because Jupiter is mostly made of gases. And if you weigh 100 pounds on Earth, so you will weigh 240 pounds, right? You'll weigh 240 pounds in Jupiter. Yes. Now let's talk about the moons of Jupiter. Jupiter has 53 named moons and another 26 awaiting official names. A lot of moons are there. Now the number has increased. Every year we do, modify this number, and you say, today let me see, number of uh, Jupiter's moon.
Ma'am, in the book it's given as 141.
Yeah, in the internet now it's given 95 moons. So a lot of moons are there. Actually, more than 50. A lot of them, and the coming future, a lot more will be added. So, and 4 of them are the biggest ones, and they are called the Galilean moons. Because it was Galileo Galilei who discovered Jupiter's 4 largest moon in 1610. And we call these Galilean moons. Which are these moons? Io, Europa, Callisto, and Ganymede. And Ganymede is the largest moon of solar system. It is bigger than Mercury, the planet.
Ma'am,
And they are,
ma'am, I have a doubt, ma'am.
please ask it after the 1 hour session. Please note it down in the chat section. And this is Io.
Please show the last slide.
And these Galilean moons were the first objects to orbit a body that was neither Earth nor the Sun.
Ma'am,
Yes.
I want to tell you that Pluto is the size of Australia.
Okay. Now, this is Europa. This is Callisto. and this is Ganymede. Now let's talk about the orbit and rotation of Jupiter. Jupiter is the only planet that has a center of mass with the sun uh, that lies outside the volume of the sun, though by only 7% of the sun's radius. The average distance between Jupiter and the sun is 778 million kilometers, and about 5.2 times the average distance from the Earth to the sun, over 5.2 astronomical units. And it completes an orbit every 11.86 years. So it's revolving around sun very fast. Now the axial tilt of Jupiter is relatively small, only 3.13 degree. As a result, the planet does not experience significant seasonal changes.
Miss, excuse me, can you go back to the previous slide for a minute? Thank you. Done, Miss.
So Jupiter's rotation is the fastest of all the solar system planets, completing a rotation on its axis in slightly less than 10 hours. And this creates an equatorial bulge, easily seen through the Earth-based amateur telescopes. And the planet is shaped as an oblate spheroid, meaning that the diameter across its equator is longer than the diameter measured between the poles, just like that of Earth. When we studied Earth yesterday, we studied about this oblate spheroid shape. Because Earth and these planets rotate faster, the central part, which is the equator, it bulges out, and the polar region are flattened, which means that if you just measure the radius of Earth from its center to the pole and center to the equator, center to the equator will be longer than that of center to the pole radius. So in the case of Jupiter, since it rotates faster, this happens. And on Jupiter, the equatorial diameter is 9,275 kilometers longer than the diameter measured through the poles. So that much difference is there, almost 10,000 kilometer difference is there between the radius um, in the polar area and the equator region. Since Jupiter is a gas planet, it does not rotate as a solid sphere, just like that of Sun. We have different, speed for the different layers in the Sun, right? For example, the equator layer, it rotates in some, say, um, to 30 days, and the polar region, it rotates, it takes only maybe say 2-3 weeks. Just like that, Jupiter.
Ma'am, 1 minute. Can you go to the previous slide?
I won't be going to the previous slide. Please don't interrupt between the classes. You'll get these slides once the classes are finished. Since Jupiter is a gas planet, it does not rotate as a solid sphere, and Jupiter's equator rotates a bit faster than its polar regions at a speed of 28,273 miles per hour. Already you need to respect the classes, okay, everybody, because in between we are talking about something. Do you like interrupting you between talking? No, right? Of course, no one will be liking that. It takes some intellectual level to talk about science. So please respect that person while they are talking, just like I respect you while you're asking questions. You all will get the slides and the recordings. So since Jupiter is a gas planet, it does not rotate as a solid sphere. and Jupiter's equator rotates a bit faster than its polar regions at a speed of 28,273 miles per hour. Now, for this reason, its middle has been stretched out. Rather than round, it is short and flat. Now, kind of like when someone spins a pizza dough really fast to stretch it out. Now, this is one of the important features that we see on the surface of Jupiter. In all the pictures of Jupiter, we can see this spot. It's called the Great Red Spot. And let's see what is this spot. The Great Red Spot of Jupiter. It's a huge, long-lasting storm in the atmosphere of the southern hemisphere of Jupiter. It's not a geological feature, but it's a storm. Since this feature is, in its atmosphere and it is long-lasting, we see at this red spot. It's in the southern hemisphere of Jupiter. It's an anticyclonic storm, much like a cyclone, okay, that we see in Bay of Bengal or hurricane or something like that. Its color is actually pink to orange. So in the pictures, we see it as red, almost red orange in color.
Ma'am, this is bigger than our Earth. This storm.
Yes, this is bigger than the Earth. Even that storm, the red spot is bigger than the Earth. That's true. And Robert Hooke, he was a popular scientist who discovered the great red spot of Jupiter in 1664. Now, about the rings of Jupiter. The planet Jupiter has a system of rings known as the rings of Jupiter or the Jovian ring system. It was a third ring system to be discovered in the solar system. First, we discovered the ring of Saturn. And how did we discover the rings of Saturn? Because it is obvious, right? It has spectacular rings. A number of rings are there combined together. And just like that, even Uranus also has a system of rings. It was first observed in 1979 by Voyager 1 spacecraft and thoroughly investigated in the 1990s by the Galileo orbiter. Saturn is not the only planet with rings, and in fact, Jupiter has a planetary ring system as well as moons that orbit the planet. The three segments of the ring system are the halo, a bright main ring, and the outer gossamer ring. So there are three sets of rings, three segments of ring for Jupiter. The first ring, the innermost, it's called halo, and the second is called main ring, and the third one is called gossamer ring. Unlike Saturn's icy ring, the rings of Jupiter appears to be composed of dust. So in the case of Saturn, it's mostly icy ring, and in the case of Jupiter, it's mostly a rocky and dusty ring. It appears that one of the rings of Jupiter was formed from material that was ejected from four satellites: Adrastea, Amalthea, Thebe, and Metis. These are the three rings. The first one, innermost ring, that is halo, and then there is main ring, and then there is two rings called gossamer ring. Halo, main ring, and gossamer ring. Now moving to the next slide. The flyby missions. There were a number of missions to the Jupiter that include Pioneer 10, which flew by Jupiter in 1973, then Pioneer 11, 1974, Then Voyager 1, 1979, Voyager 2, then Ulysses mission in 1992 and 2004. Then there was Cassini-Huygens mission. Cassini-Huygens was studying Saturn, and on the way to Saturn, it studied about Jupiter and its moons. And there was New Horizons mission towards Pluto in 2007. Sometimes it's called the savior planet. Maybe you have heard about it. So the question is, does Jupiter protect Earth from comets and asteroids? Actually, the answer is yes. Scientists believe that Jupiter's gravitational field is pushing comets and asteroids, which are approaching the Earth, away from the inner planets, diverting them to the outer planets and thus averting possible catastrophe. So, as this planet Jupiter is so big and massive, it will attract all these, asteroids which are approaching the inner planets. So, in one way or another, Jupiter is protecting us. Basically, three types of objects, namely main belt asteroid, Kuiper belt comets, and Oort cloud comets, pose a threat to both Jupiter and the Earth. Of these, the main belt asteroids follow an orbit which is between that of Mars and Jupiter. Now, Kuiper belt comets are found to follow a path which is close to the orbit of the Neptune. We studied about Kuiper belt comets yesterday, and there are long-term comets which are coming from the Oort cloud, right? And so, yeah, that's how Jupiter protects us from catastrophic heating events. Yes, so that's the Jupiter slide, and let's move to the next one. The Saturn slide. Let me share the screen again. Hopefully you can see the slide.
Yes, ma'am.
Yes. So Saturn is the real Lord of Rings. And these are the basic facts. Sixth planet from the Sun. Yes, Saturn is the sixth planet from the Sun. And it is the second largest planet in the solar system after Jupiter. Jupiter had 3 rings, right? And Saturn has 17 flat rings. There are 82, like more than 82 moons can be there.
Miss, now
And
there
today,
are 146.
see, every year it is coming, it is changing, right? Because now next year you just look, it will be more than that. As of January 2022, it was 82, and every year it will become, because we are finding new and new moons. We'll come back to the class. These are the ancient observations. Farthest planet prehistoric astronomers knew. It is one of the farthest planets. Neptune and Uranus were discovered later, but up to Saturn we knew that they exist because we can see it with naked eye. And the distance from the Sun is it's almost 9.5 times as far as Earth. Consider the distance between Sun and Earth, that is 1 AU, right? Again, it is 9.5 AU. Now, one solar revolution will take 29.5 Earth days. It was a planet that can be seen by Earth with the naked eye, but the rings cannot. Yeah, only we can see the shiny thing, just like a star, but we cannot see its rings. But with a telescope, of course, we can. So Galileo discovered, it was Galileo for the first time discovered that Saturn had rings. It was in 1610, though it's believed they were moons on either side. So first it was believed that it's not rings but moons on either side. But Christian Huygens, he was the first one to coin the word rings in 1965. Now, Where is Saturn located actually? It orbits the Sun at a distance of about 1.4 billion kilometers. That is 870 million miles. And Saturn is about 9.5 times as far from the Sun as the Earth. And Saturn is almost twice as far from the Sun as Jupiter, the fifth planet in the solar system. So consider the distance between Sun to Jupiter. That much distance again is there between Jupiter and Saturn. Now let's talk about how big is Saturn. Of course, it's the second largest planet in the solar system, and it could contain 95 Earth masses. It's also a gas giant, just like Jupiter, Uranus, and Neptune. These four planets together, they are called gaseous planet, right? Sometimes Uranus and Neptune are also called icy planet. Its diameter is 10 times that of Earth. Here you can see a comparison of a schematic comparison of Jupiter, Saturn, Uranus, Neptune, and Earth. So this is the planetary size comparison. This much Earth, Saturn could say almost 90. And if Saturn is so much more massive than Earth, why is it said that Saturn could float in water? Why is that? It's because of its low density. Earth is the densest planet, while Saturn is the less densest planet, lightest planet. It has lowest density of all the planets, and it has a density 1/10 that of Earth. It's because Earth has heavy elements in it. For example, Earth's outer core and core region contains, highly packed nickel and iron. So it's said that Saturn could
Ma'am,
float
its
in
rings are
water.
dense, so it wouldn't float with its rings.
Rings. See, what about the rings? Rings are not solid, solid rings. There are gaps between the rings. If you examine, when we observe the rings from far away, we will see that okay, it's continuous. But as we go near to it, we'll understand that it's not like highly packed and dense
It's
rings,
like an
but not.
It's like
Yeah,
an asteroid belt.
exactly.
Yes, but I'm saying that the materials of the moons and the rocky particles of the rings, they wouldn't float because they're dense.
Ayo, each one of it you are taking, no, it won't. And the notion of Saturn sinking or floating is just an experimental thing, like a logical experimental
Yes,
thing.
yes.
Yeah.
Miss, it is because the mass and the volume of Saturn is almost the same.
Oh, yeah. So let's ask, what is Saturn made of? So primarily a ball of gas with no solid surface. It's a ball of gas with no solid surface. 94% of hydrogen, 6% of helium, small amounts of methane and ammonia. When we talk about Saturn can float, it doesn't mean that along with the ring, but the planet Saturn. Okay. And yeah, there is 94% of hydrogen and 6% of helium. Small amounts of methane and ammonia. And detailed analysis of Saturn's gravitational field led to the astronomers to believe that the deepest interior of Saturn must consist of molten rock core. It has the same size of Earth but more mass, it says. Here, it's the molecular hydrogen and helium, then the metallic hydrogen and helium, and an isotope. Mostly it's made of hydrogen, helium, and methane. Now you talk about the Jupiter in the previous slide, we found that the cloud tops, then ammonia crystals, ammonium hydrosulfide clouds, ice crystal. Now these are just, when you talk about such a figure, it's just, the overall picture of it. But there are different layers delineated by different sciences. Now talk about Saturn's surface. Saturn is a giant ball of gas, believed to have no solid surface, inner core of iron and rocky material, outer core of ammonia, iron, and doesn't have a solid surface. It's inner core of iron and rocky material. It has an inner core of iron, made of iron, and it's mostly rocky, solid. And there is outer core which is liquid or molten. It is made of ammonia, methane, and water. Now there is liquid metallic hydrogen that surrounds outer core. And this is Sun's atmosphere. Sometimes we can see different kinds of clouds. For example, in this figure, you can see hexagon clouds. The surface and atmosphere merge actually, because both are, gaseous in nature, right? And dense clouds cover the Saturn. Differences in temperature and altitude causes patterns and color differences in the cloud tops. So it is the temperature differences and altitude differences. So when we look from an observational view, like a satellite or so, we'll see that it has different color and different particular shapes. Yes. So this is the internal structure of Saturn. And first, the bottom of the cone, we have rocky Saturn's core, and above that there are icy layers, outer cores, and then there is metallic hydrogen layer, and then molecular hydrogen layer.
Ma'am, what is the temperature of Saturn?
Oh, it has different temperatures in different places, like
Like
in
in
the
its
interior.
molecular hydrogen atmosphere.
Temperature of Saturn's atmosphere, right? Yes, it is minus 288 degrees Fahrenheit or minus 178 degrees Celsius. Okay, minus
Then
178 degrees.
is it like hot in Saturn?
No, in the surface it is very cold, but as the internal structure it goes, it can be hotter, just
So
like any other
then
planet.
ice would be hot inside the Saturn, like
Ice, in the sense, it is say solid particles. Not in the see, temperature is not only the reason for formation of ice. It can be pressure also. In a
Okay.
highly pressurized system, also ice can form, but not the temperature.
Okay.
Yeah. Who is scribbling the screen again? Okay, I will. I think Edumitra people will, take some action against such kids and their, I mean, their account, because it's actually an offense, the police offense, making problems in class. So of course I think Edumitra will take actions against that. Thank you. Now there is aphelion and perihelion for Saturn's orbit, and the aphelion is 10.1 astronomical unit while perihelion is 9 astronomical unit. So it has elliptical orbit. And the period of orbit is 29.46 Earth years. And it has an axis tilt of 27 degrees, and the eccentricity means it's a measure of how elliptical the axis is.
Excuse me, ma'am.
Yes, questions can be asked after the classes. Is that fine?
Yes, ma'am.
Yeah. And rotations is the second fastest of non-planets. Saturn rotates 10 hours 39 minutes on its own axis. Yes. So how long is a year on Saturn? It takes 29.5 Earth days, Earth years actually, to travel once around the Sun. So one Saturn year is about 30 Earth years. Now let's look at the shape of Saturn. The rapid rotation causes the planet to bulge, and the oblate spheroid flattened at poles and bulges at equator, just like any other planet. We studied about this kind of structure in Earth's slide and Jupiter's slide, right? Yes. And the next question is, why isn't Saturn the same color as Jupiter? We saw
Yes,
that
that was
there.
my question.
Yeah, okay, very good. So we found that almost the components are similar, right? Almost the components are similar. So how can Saturn and the Jupiter be of same different colors? So the answer to this question is Saturn is the world of white and pastel yellow cloud layers, and Jupiter is bright yellow, oranges, and red in exotic swirls and storms. Now, near the top of atmosphere, ammonia becomes cold enough to crystallize into ice particle cloud. But Saturn is colder than Jupiter. So the colorful ammonia clouds are deeper in the atmosphere. This is the main reason. It's a
Yes, it's
temperature
farther away
difference.
from the sun, so it's colder.
Yes, it is away from the sun than that of Jupiter. So this is the major difference. A major reason why why there is different colors for Jupiter and Saturn. So what's the answer? The top of the atmosphere, ammonia becomes cold enough to crystallize into icy particle cloud. But Saturn is colder than Jupiter. So these colorful ammonia clouds are beneath the surface or deeper in the atmosphere. Now, yeah, this is the summary of the class. Yes. Now let's talk about the rings of Saturn. The Saturn's rings were discovered by Galileo in 1600s. These rings tilt at same angle at the equator. So you know how these rings in equator has a tilt. Of course, it can be, but the rings are also in same angles to the equator. And these are each of single small of them can be 20 meters thick, but overall the thickness of the rings, if you talk about, is let me see. It is almost 1 kilometers. By spacecraft, so there are some Earth-based telescopes. These observation indicates that Saturn's rings are about 1 kilometer thick, while spacecraft measurements and theoretical consideration gives an upper bound of 100 meters, more than 100. So 1 kilometer, 100 meter can be there. In each of these, these can be. We are not talking about the length, okay? We are not talking about the thickness of the clouds. And if you ask the length of the, the spread length of Saturn's rings, it can be some 282,000 kilometers, and with a thickness of just 1 kilometer, or sometimes somewhere it is 20 kilometers, somewhere it is 30, just like that. Some it is 1 kilometer. Mostly on an average it is 20 meters thick. Now 93% of water ice composition is there in the rings, and 7% amorphous carbon is also present in the ring. There are 7 total rings, and they are made up of thousands of ringlets made up of billions of ice particles. And the particles ranges in size from dust to a car. This is an example of how rings can be seen when it is closer.
Ma'am, can we stand on its rings like
No.
on a rock?
If you are correctly, but it will be, if it is, big enough, maybe you can.
Okay.
But that region is not at all safe. Continuously, things are, all of them are not moving in same speed. Some are moving faster, and even collisions are happening now also.
Okay.
There are 2 main ring theories. Theory 1 is the remnant of destroyed moon of Saturn, and the second theory is the rings left over from original nebula material that formed the Saturn. So these are the 2 theories how the rings are formed. So some ice comes from the moon, Enceladus ice volcano. So there is this, satellite for Saturn that is called Enceladus. Uh, it just I told you about the Cassini-Huygens missions, right? So this Huygens was actually an impactor, a lander that was supposed to land in the biggest satellite of Saturn, which is Titan. And there was an orbiter called Cassini, and this Cassini actually found that there is a water molecule coming from somewhere. It's like sprayed from somewhere. And when it was analyzed, they understood that it is coming from the stripes, the gaps present in the surface of the satellite Enceladus. So it is proposed that some 50-kilometer crust beneath the 50-kilometer crust of Enceladus, there could be an ocean. So the temperature, the tilt of axis. We talked about the tilt for the axis of Saturn, and since there is this tilt, it experiences seasons. Each season is 7.5 Earth years because it takes 29 times longer than the Earth's revolve. And the top clouds are minus 175 degrees Celsius, and below the clouds it's hot. The planet gives off 2.5 times the heat it receives from the sun. Now, yeah, the moon number. We just talked about the moon. A lot of moons are there now, but there are many moons, while the largest is Titan, and it is larger than Mercury and Pluto, and it contains an atmosphere. So Titan is
It said that, ma'am, we can can be lived on Titan.
yes. So it said that Titan is actually a planet like, satellite like that of Earth, which means it has an atmosphere. I think Titan is one of the rarest satellite with atmosphere. And now let's talk about the space exploration that is going to study Saturn. The first one is in 1979, the Pioneer 11, and there was Voyager 1 and 2. Then Cassini-Huygens, the first spacecraft to land on a moon other than Earth. Here you can see pictures of Pioneer spacecraft. This is Voyager 1 and 2. And this is a Cassini-Huygens mission. Yes. So this is the Saturn side. It is almost 6:26. Yeah, thank you, everybody.
Thank you, ma'am.